We've got the Chapter 4 final review notes today. So have your stuff open. What page is this on? I don't know. It's Chapter 4. It's in the left side box. The objective, students will be able to recognize congruent figures in their corresponding parts, prove triangles congruent using side, 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 angle, and angle, angle, side. Use triangle congruence in corresponding parts of congruent triangles. Prove that parts of two triangles are congruent. Use and apply properties of isosceles and equilateral triangles. Prove right triangles congruent using the hypotenuse leg theorem. And identify congruent overlapping triangles and proving two triangles congruent using other congruent triangles. It's crazy. It's a lot of material. That was Chapter 4. Okay? So when we're looking over this, make sure you recognize we're pulling that information in, and your Chapter 4 notes should be out. Your Chapter 4 note sheet for your test should be out, and you should be looking over, making improvements to it. Okay, because you get the opportunity to have that on the test. So make sure that you're making those improvements. The first thing, we're working on recognizing congruent figures in their corresponding parts. So all I want you to do, if I can get this to cooperate, is list the sides that are congruent and list the angles that are congruent. I would do the angles first. Hint, hint, hint. So go ahead and get that done. Nancy, can you close that down and participate with these? Okay, so go ahead and get that done. Do the angles first, and then do the other stuff. Angles first, and then use your angles to help you get sides. Okay, it's kind of a mental gymnastics to do it the other way around. Got the first half done quite quickly. I just looked at the angles of one triangle and went ABC all the way down. Now, A is blank. Well, so is E. Angle E. B has double. D has double. Cool. C has a single. So does F. Are you okay with what I got? And perhaps right now would be better for me to consider the fact that I should write the triangle congruence statement so I can do the sides faster. So I've got triangle ABC congruent to triangle EDF. Okay? Totally based on the way the angles are connected, but I wrote it quite quickly. And now I can go, hey, you know, I got side AB, corresponding sides. I got side BC, corresponding sides, and side AC, bless you. I've got that going on. I've got the sides. Remember, I just wrote the triangle congruence statement. AB, ED is in the same positions. BC, DF is in the same positions. AC, EF is in the same positions. Done. Okay, got it all set up. Are there any questions about it? Okay, me talking about corresponding congruent sides and angles. I would always do angles first, then write my congruent statement and get the sides in. Using the statement below, fill in the missing measurements of the figures. I need you to have that tilde on top of the equal sign to make it a congruence. We can't have shapes equal, we can have them congruent. Okay? Now, based on congruence and congruence alone, S and R are congruent. Okay? What do you know about angle R? What's the measure? 102. Okay. Well, based on congruence, H and O are in the same positions. What do you know about angle H? 105. Mr. Bianchi, if you could close that down. Zimmerman, close down your computers. Thank you. So we got 105. Okay. Now, next, as we're still looking through this, we got angle A. Angle A and angle C are both blank. We might be able to find something there. Angle K and angle P. What do we know? 127. Okay, what about angle S? 113, because it's the same as angle E. What do you know about length RS? It's kind of low, but it's there. What do you know about the length segment RS? Okay. What do you know about the length of segment RO? We doing okay? Now, I got one more thing that we can find. We know something and be able to find angle A's value. Anybody recall it? Total interior angle value of a polygon. How would we use that? Mr. O'Hare. N minus 2 times 180 will give me my total interior angle value of a polygon. Okay, and this is a 5-sided figure, so 5 is n. Thank you, dear. This is a 5-sided figure, so 5 is n. So I got 3 times 180. Now, why am I doing that? We can find angle A. We have the skills and technology to get it done. So take out your calculator, okay, to find angle A, find the measure. We're finding the measure of angle A. That's what we're looking for. Well, that means that 105 plus 102 plus 113 plus 127 plus x are all equal to 540. Somebody's got to move this stuff over. So that is equal to 540. Are you okay with what I got going on? So what's angle A? What was it? 93? Is you okay with 93? Is everybody okay with 93? Okay, so we did that, and this all added up to what then? 447. So we got 447 plus x equal 540, and we found out that x was 93. So that means angle A is 93 degrees. And incidentally, so is angle C. So we have enough information now to do that type of stuff, knowing it's a regular polygon, or not even a regular polygon, but this one is just that total interior angle value of a 5-sided figure is 540, and we'll be able to find that missing side, or missing angle measure. Now, I need you to make this change on this one. These need to be there. I don't think they're there on your picture. Okay? I want you to answer 1 and 2. I know you don't have numbers there, but I put them in here so I could actually identify them with you instead of, hell, we'll do that one. Which one of the statements would you use? Angle, side, angle, angle, side, angle, side, side, or HL? And we're going to talk about each. And number 1, which one would we use? Ideas? Yes. Side, angle, side. Correctamundo. That angle is the included angle between the two sides. So that is side, angle, side congruence. Okay. And the next one, it's a right triangle. It has a right angle. Okay. The markings allow me to see that I have the legs congruent and the hypotenuse congruent. Which one do I use here? Hypotenuse leg. Fantastic. Thank you, Johnny. So hypotenuse leg congruence allows me to do that. Must be used with a right triangle. If it's not right, I can't use it. Now, the next two. I think you need to make this change. This angle needs to be in there. I don't think you have them. Oh, you do. Fantastic. My piece, my notes did not. So in number 3, what should I be using? You okay with side, side, side? All right. In number 4, talk to your row partner about number 4. Okay, got a question. When I go to a Hobby Lobby and I get a car model, a model car, maybe it's a 1965 Stingray, Does it look like the real life model? I mean, if I pick up a model car to be exactly the same make and model of the real car, do they look alike? What's the difference? Their size, right? I mean, and their weight. I mean, I ain't going to go to the Hobby Lobby, pull it off a shelf, and then just walk up to the register and pay for it without keys, right? If it was the exact identical thing. But if I go in there and I purchase this, I have a replica of the real thing. It is the same shape, different size. The word we use when we talk about things like that is the S word, similar, right? I have two triangles here that have the same shape. Size is determined by congruence of a segment. If they're going to be the same size, congruent sides have to be included. In this particular case, I have two triangles that are similar by something called angle-angle similarity. It's something we're going to learn about in chapter 7 for first thing, second semester. This is not congruent because I have no sides. So right now we know not congruent. Now what I'd like you to do is take this moment or opportunity to draw two triangles. They should be similar. I should say try to draw two triangles that are congruent. Okay, and then mark them according to angle side angle rules. Okay, mark them according to angle side angle rules. I know I cheated, didn't I? They're pretty similar. All right, so here's the thing. I want angle side angle. An angle, a side, and an angle. When I'm working with angle side angle, that side is called the included side. Okay, it is attached to the two angles. Now, I was asked first period about the difference if I were to do angle side. What would angle side look like in comparison? Angle would be two angles and a side. Okay? The side is not included between the two angles. All right? And that's the difference between the use of those two. So I want to make sure you knew that and saw that. This is kind of an aside to help you with notes. Okay? Now, we got that? Good. Now, we got this proof to get on to. These two of them. Okay? Triangle proofs. Let's talk about them. I've got angle KBC, and angle ACB congruent. I've got angle K and angle A congruent. Do you see that BC is congruent to CB here? What do you see in the reflection in the mirror in the morning? Your reflection, right? You know, you see yourself, except you move your right arm, your left arm moves over there. It's kind of weird. That when you look in the mirror, that it's like a personal stalker. It's always with you. You wave, they wave, mimicking you, teasing you, poking fun at you when you poke yourself in the eye. Okay, here's the deal. What I want you to realize is that I've got BC and CB. It's congruent to itself by reflexive property. Once I do that, I have two triangles congruent to each other by angle side. And I'm saying this because I've got to have the two triangles congruent to one another in order to use corresponding parts of congruent triangles are congruent, CPCTC, to have parts of those triangles congruent. Because they want me to prove that segment KB is congruent to segment AC. And to do that, I must prove the triangles. Okay? So, I gave us the steps. the first time I'm looking at this proof, if I didn't know anything, I should at least write down the given, okay? So I've got my given going on. You okay with that? Got my given written down. Are there any questions about my given? Now, keep in mind, I talked about reflexive, angle side, and CP/CTC. Those are our steps. Or I should say our reasons for our steps. Fill in the rest. Go. Okay, on your test, you can have a fill it in where you will just drag and drop steps and reasons, okay, into your proof. You can have fill in the one missing blank or two missing blanks by a drag and drop with a word bank. You could just have one where it's an open-ended question, you just type in your response. So those things can happen. That's why we're going through this. So reflexive, I got segment BC congruent to segment CB, okay? Angle side, I have my two triangles congruent. Now, you might have your triangle order different than mine, but what's necessary to keep in mind is that B and C have to be in the same position. K and A must be in the same position, and C and B must be in the same position. Is it making sense? Now, my last thing. I got corresponding parts congruent, triangles are congruent. That's what I was asked to prove. So that's where I'm going. Okay? Now, our next deal. I've got another proof. I've got two triangles in a bow tie configuration. So what should I be looking for? Vertical angles. And once I get those vertical angles, can I prove the two triangles congruent? And by which theorem? I'm going to get it done. I just got people still writing on that, so I was just dragging my feet until they did. I got this marked. We talked about vertical angles. So how are these two triangles now congruent? Because we're done with the triangles being congruent if you can come up with the tool to help us prove them congruent. Which one would it be? Look at the picture. Side, angle, side. See, I've got a side, I got an angle, I got both. Cool, side, angle, side. It's like shopping. I've got a side, angle, side. I pulled that one out. So I got my given, and I got the vertical angle thing, and I got side, angle, side. Well, gosh, whiz bangerangs. I just proved the triangle's congruent, and now I can talk about the parts of those triangles being congruent by CP/CTC. Corresponding parts congruent, triangles are congruent. Woohoo! So we got that going on. Now, here's the deal. Next thing. Angles. Okay, we got some angles going down. So I'm looking at students will be able to use and apply properties of isosceles, or I should maybe perhaps say isosceles, and equilateral angles, triangles, as we go through these. Remember, scalene is a triangle classification for sides. Isosceles is a triangle classification for sides. Equilateral is a triangle classification for sides. Okay? So those are the big three. Scalene, no sides in common. Isosceles, two sides in common. Equilateral, all three sides are in common. Sorry, I lost track of which one I was talking about. Here's the deal. When I have two sides in common, I have two angles in common. When I have three sides in common, I have three angles in common. And if I'm looking at this one, I've got two sides in common. This has to be 54. Has to be, because it's isosceles. And the angles that are congruent are opposite the sides that are congruent. So those are opposites. What's going on right there? What can I classify dB as? If I had a list of words, and we did this in chapter 5, what could I call dB? I want you to think about it. I've got, what do you got? Angle bisector, perfect. I've got two angles that are congruent. So I'm looking at the idea that not only is that x, but this is x. And I'm going to use that with triangle sum theorem. Triangle sum theorem is all three interior angles of a triangle add up to 180. So now I have 54 plus 54 plus 2x's, right, is equal to 180. And that is my three angles of that triangle ABC. I got 108 plus 2x equal 180. 2x is equal to 72. X is equal to 36. But that's also 36 degrees. Both of those things. Are there any questions on what I did? We talked about classifications. We talked about isosceles. We talked about equilateral. Talked about scalene. Keep in mind angle classifications. Triangles are also classified by angles. Acute angles, angles between 0 and 90. Right angles, angles that are exactly 90. Obtuse angles, angles that are between 90 and 180. And the triangle's always classified by its largest measured angle. Okay? Does that make sense? So it's angle and sides when we classify. Johnny, question?
I said 54 plus 90 equals x equals 180.
We don't know that this is 90. So we can't make the assumption it's a right triangle. It's not marked. And as we finished out, we can now prove that ADB is 90 because of the values. So we can't make the assumption based on the information given, because all I would have to do to make that change for the assumption is say, okay, this is 50. And now I've changed it. And if those are both 50 as we go through, that's 100. This makes 80 up here, and these are both 40. And that makes it 90 as well. I wonder if that's always going to be that way. Not an average. Well, yeah, it's going to have to be. Oh, excuse me, I thought I turned this off. Okay, it's going to have to be on that. Okay, when we look at that. But now let's talk about some properties, because maybe it is. Called it an angle bisector. What type of triangle do we know this to be? Isosceles. Since I have an isosceles triangle and I have an angle bisector coming from the vertex angle, and I know it's isosceles, that means it's splitting the base into two equal parts. And that's got to be 90 degrees because it's the angle bisector of an isosceles triangle because of perpendicular bisector rules. Perpendicular bisector would say that the distance from the endpoints of the segment being bisected back to a point on the segment doing the bisecting is always the same. Okay? So then, yes, it would have to always be 90. Okay? In an isosceles triangle. Okay, you okay with that? Okay. So now we've got more than one way, but we are able to pull out reasons for why. Okay? Are there any other questions with that? Now, you guys have 4 more questions. Let's go 1 and 2. Find the missing measures of angles, please. Find the missing measures of angles, please. Isosceles, measure of angle 1 is equal to 30. Triangle sum theorem, total interior angle value of a triangle is 180. I got two 30 degrees, that's 60. So 180 minus 60 is equal to 120. I know it doesn't look like it, but the measure of angle 2 here is equal to 120. It's not about what it looks like, it's about the properties we're applying. Okay? So in question 2, I know they're not numbered, so I put in a 2. I know, it's pretty creative of me, right? Okay, so in question 2, I've got base angles being congruent, that's isosceles. So if I go 180 minus 112, I get 68. All right. So 68 degrees. 68 degrees divided by 2 is 34 apiece. So the measure of angle 1 is equal to the measure of angle 2, which is equals 34 degrees. Let's slide those over there. Now, the last two. What do you know about question 3, we'll call it, in our question 4? What do you know about question 3 right now? It's equilateral. How do you know? Them little dashes got them tick marks in approximately the center of that side. And each one of those sides are how long? 5 inches, because them tick marks mean that they're all the same. Okay? And because it's equilateral, it's equiangular as well. And we know that 3 angles that are the same equal 180, and therefore each of them got to be 60. So the measure of each angle, the measure of angle 1 is equal to the measure of angle 2, which equals the measure of angle 3 is all 60 degrees. Pretty cool stuff as we go through this, huh? Now, last one. I got a 60 degrees. I've got this is congruent to that. Did you see how I figured that out? Because they're both 7 centimeters. So what do I know automatically before I even do any calculations about angle 2? Angle 2 is what? Because it's base angles of an isosceles triangle. This happens to be my vertex angle. That's my vertex angle. Base angle, because these are congruent. So the measure of angle 2, by property, 60 degrees. Do you have an inkling of what measure of angle 1 might be? 60 degrees, because I already got two 60 degrees. The third one has to be 60 degrees. So the measure of angle 1 is also 60 degrees. So what type of triangle is this? Equilateral. And my missing base side is how long? 7 centimeters, because they're all the same. Okay, awesome. Now, that's notes for today. And y'all got a summary statement off the objective. Students be prepared for the Chapter 4 questions on the final. So write a couple sentences about something that you learned today, about the learning objective, and then score yourself from 0 to 4. Okay? But remember, as you're going through your review today, make sure you ask questions. As you go through the review a second time today, notice how I said that? A second time. When you go through it a second time today, make sure you clarify things and you're doing well and you understand them. Okay, just don't shoot through and give me a bunch of answers, because I have news for you, the test doesn't have those. You got to make sure you know better and show your work and be able to complete the work so you're successful. Okay? Okay, thanks folks.